Hi, Eric. Good morning.
Hello, Jerry.
Okay, pleasure to have you here. Pleasure to meet you for the first time. And thanks for coming.
Yeah,
So,
pleasure's mine.
um, would you mind to introduce yourself?
Yeah, sure. So my name is Eric. I'm working as software developer for 10 years now. I work at Nubank. It's probably the most famous Clojure enterprise nowadays. Um, I'm from Brazil, São Paulo, and that's it.
Sao Paulo is now a capital of closure, it seems to me.
Yeah,
I'm from North Carolina.
yeah,
Okay, um, so besides being a closure developer, you have been involved in a bunch of things, and let's go through all of them. From the things I know about you, one of them is that you are working on multiple language servers, and from what I understand, there are differences. It's not like one protocol that is observed and done by all languages, but there are really differences. So, what's the anatomy of language server, and uh, are there extensions to the protocol, or is that like when you create something new because the language is somehow unique, you expect editors to modify because you extended the protocol?
yeah. Like Microsoft created that because they faced a lot of problems when creating Visual Studio Code. So they thought that must be some better way to do this. Like if we have some kind of standard, it would be really way easier to integrate with the language, right? So they created this protocol, which is just a whole PDF section, a web page nowadays. So it's just like explaining how you should follow this protocol. So you can have like two sites to integrate using this protocol, which are the LSP clients and the LSP servers. So a server is just like a program that understands that language. So for example, a Java LSP server is just a program that understands the Java language and communicates via std in and std out uh, via JSON. So they just receive a lot of JSON and respond with more JSON. So this is how a server works. And the clients are what we know as the text editors. So uh, clearly this editor needs to understand the LSP protocol, so it needs to have like plugins to understand that. But after having this configured, you can like integrate with I don't know, lots of language servers because you are using this protocol.
Yes, yes. And so when you implement a language server itself, what's the anatomy of that? Like, what parts does it have, and how is it implemented?
Yeah, that's a good question because you asked about the how much extensible it is, right? So
Yes.
protocol is really good on this part because it defines like methods, requests that it should accept or notifications, but it doesn't say it's only that. Like, for example, there are multiple language servers, including Clojure-lsp, that has extension points like new requests because that language is a little bit different. So you can add extensions. For example, the Dart language server for Flutter, for example, they have custom extension points to like draw lines on your editor for your widgets. So that's something that only exists for Flutter, I think. So, but they made that on the LSP server because it makes sense for them. So uh, we do that. We can see how much extensible is that because, for example, we have like the LSP for CLJ library. It's
Yeah.
a library that we created to like code LSP servers and clients in Clojure, and it's so extensible that to define new service, you just need to implement a def method for a def multi, and that's it. So
Yeah.
just start working. So the anatomy of those LSP is like you have like this library I mentioned tries to like be the foundation for those things. So you don't need to worry about like the communication, how I should serialize the JSON, following JSON RPC, or how should I handle the threads to communicate with all those async requests and things like that. So there is this complex part that those libraries try to fix and solve for you. So you can just aim on the product, like on the server itself, like the language, you know. So the anatomy is basically you have the front end side, like the handler of the thing. So it receives JSON and should publish JSON or respond to JSON as well. And you have like the handlers that need to do what need to do. So after receiving this, you can delegate to do what you should do. So you can, I don't know, process something, keep them in memory atom or something like that, and just respond with more JSON. So this is the most important part of the server side, while the client side does have the same thing, but it's easier about the communication, just send and receives, but needs to plot things on the IDE, right? So
Yeah.
show pop-ups, go to open files, do something on the file system. So they are different responsibilities, but uh, they have like the common communication.
Yes, yes. Is it more difficult to implement language server for dynamic or static language?
Yeah, that's a good question. I would say it's way easier for static languages. Why? Because you already have like the everything on the code there. You don't need to infer those things, you know. So one of the major things we have for Clojure is we do have like locals, like I don't know a full local, but what is that? What kind of? We know that in runtime this could be, like, for example, a string or an integer, but we don't know that just looking at the code. So it's way harder, for example, that we use CLJ Condo under the hood to do like the analysis part of the language. So Clojure-lsp use CLJ Condor the hood for that. And CLJ Condor needs to like analyze a whole code to understand this kind of thing. So it does have like a type support for some things, some parts of the code. But for example, it's way easier for us to integrate with Java and things like that because of this, you know. So for static analysis, for example, I don't know, Flutter itself has some kind of those parts, and it's way easier for the language server to understand when we have like the code telling what is that, you know.
Yes, yes. It's always the evaluation is always based on files, right? So if you run REPL and dynamically start modifying things, language server is not going to help you in any way. Like it can help you based on what it knows about files,
Yeah,
right?
that's funny because the language server is agnostic of files.
Uh-huh.
Like it knows URIs, so you have like the location of a resource, like a URL, and you know that this belongs to this resource, but it doesn't need to be a local file, you know.
Yeah,
Uh, they mention about this because it's possible to have remote LSPs.
yeah,
So Emacs, for example, has Trump, which is like a way to connect to remote file systems. And although it's possible to have LSPs, it's pretty common to have like the servers coupled with the file system. You know, Clojure LSP itself is a little bit coupled with the file system nowadays, but it's something that the protocol is not a hard limit on the protocol, you know.
yes, yes. I was thinking what it would it mean to implement LSP for language like Smalltalk or other languages where basically you don't have source code stored on your hard drive, but you have an image that's running and you can modify it. You can change the application as it's running, and that's the way how to work. But if it's not tied to the file system, potentially you can say this environment is actually the file system,
Yeah,
Uh,
definitely. Like it's really possible. I think the only problem is that most plugins and like LSP integrations don't really rely on that. Like they expect that the file is present or saved on disk or something like that. So you probably will need to like fix some place or other, but it's really possible. Like the LSP protocol allows that.
Also, 90%, not 90, 99% of developers are not in the world where programming is so dynamic that you would be defining whole namespaces in memory while the application is running without having any representation in the file system.
Yeah, we can see that on Clojure. Like it's possible. It's easier to do that, right?
It's not just possible, it's actually, I think it's the future of programming in some way. I have seen prototypes of like the AI is generating a game as you play, and you might decide, let's say, okay, now it's like a 3D shooter game. I want to make it more like platform game, more jumping, and instead of enemies, I want traps. And it will start writing code that will be closer to platform games, and you will have traps and jumping. So actually,
Yeah.
in the future, we might have developers who are creating code that's on the run and generating code.
Yes. Yeah, it
Uh,
makes sense.
it will be insane to debug it, I
Yeah.
guess. Yes. So if you look at Clojure, like language server, you also support Dart, right? And how is Clojure language server different from other languages or other language servers?
Yeah, that's a really good question. Like, one of the language itself is different. Like, we have a Lisp, or most of the languages are not Lisp based. So when we look to the protocol itself, it's pretty common to see how the protocol was a little bit biased about like TypeScript language, Java language, and things like that. So, but they understand there are functional languages, but they are not that friendly with Lisp-based languages. So sometimes we face one issue or other related to how the protocol exists, but no major issue at the moment. I think the most challenging thing about developing this language server is understand the AST, like the tree of the language, because other languages, for example, Dart and um, Java, they have like really complex libraries for the Dart compiler itself knows how to generate an AST, like the language tree hierarchy. So tooling can understand this. So the Dart LSP itself uses the Dart compiler to know analysis of the languages and provide to the LSP. And the same thing for Rust. So Clojure, I think, was the hardest because we didn't have any tool doing that. So we only had like CLJ Condo exporting analysis on 2020 or something like that. So it's the only tool that does this really well. And if we had like something built in Clojure or something like that that the other languages are doing, that would help a lot. So I
Yeah.
think this is the major problem to implement a language server for Clojure. The other thing is it's sometimes is a little bit uh, harder to explain to developers the difference between the LSP and the REPL, because there are a lot of collisions between features, because when we didn't have LSP, we did have like the REPL with a lot of features like fine definition references and a lot of LSP features on the REPL. And now we have the same on LSP. So what should I rely? When I should I rely on each other? Like they do the both things, but
Mhm.
one uses static analysis of your code and doesn't need the REPL at all. The other is use the runtime analysis of your REPL,
Yeah.
but the REPL with all the namespaces knowing your namespaces. So there are trade-offs,
Yeah. Nowadays, if you were building your own programming language, do you think building language server at the same time is like a must-have nowadays to drive the adoption?
Yeah, definitely. Like I'm really inspired by the Dart language because I saw Flutter grow since the
Yeah.
beginning, and I like integrated with. I'm owner of LSP Dart. That is another project for integrating Emacs with the Dart language. So
Yeah.
I like joined forces and worked a lot with the maintainers of the Dart language server, and I saw how this is really important when building the language. Like they used to plan the features of the language alongside with the LSP and the tooling.
Yeah.
So that is way better for planning your features and having parity of the features with the tooling. So the tooling is really coupled to the features, so it works together, it works really good. So I think it's a must have nowadays for any language, like not necessarily the LSP,
Yeah.
but like the analysis part of the language. It's something
Yes.
that the language needs to have. If for some reason another editor creates another LSP protocol for whatever reason, or following other standards, okay, that could happen. But the analysis part is still something that will work and could follow this protocol.
Okay. Okay. Um, so now let me touch for a second on large language models. So now LSPs are used by individuals when they write code, or sometimes when they check out code from somebody else and they want to see if it's okay or not. When you have LLMs, so now it's quite common that you ask those agents to run linters like CLJ Condo, to run tests, and so on. Still, for example, Claude, all the time it forgets to close last parenthesis in Clojure code, for example. When I work with this, I know it. I add the parenthesis and it's all good. But when you let it cook by itself, it might spend a lot of time doing this. How could LLMs use language protocols or language servers and to let's say generate code faster and better?
Yeah, I think like the good thing about the LSP protocol is that it standardize one thing that's really important, that is the communication between your editor with whatever you are working. Like if this is a language, it could have like a LSP for that language. If that's a LLM based backend, it could work as well. So we do have like LSP servers for other things that are not language. For example, LSP servers for my custom Markdown language, or for example, for my LLM server. That's something that's already happening.
Mhm.
So I think that's where LSP helps. It helps like glue. It's the glue to like have this, for example, Cloud running on your machine, and you want to like to see something on the editor, like, oh, did you mean this, or do you want to fix this, do you want to like code actions for the LSP or completion for those things. So these are all capabilities of the LSP that could be like integrated with those backend LLM based servers. So I see it as a really important thing. I know it's happening. I'm not aware of any famous one, but I know there are people creating LSP for those things.
Yes, yes. Okay, now let's speak about something completely different, and it's NixOS. You are the only person in my life I know who is using Nix. Even when, like online, uh, the community of Nix users are usually very vocal about the distro, how good it is, and so on. So sell me this pen, sell me Nix.
Yeah, that's a good. Like I'm a Linux user since my beginning on this area, but I always use it Ubuntu and Debian as the main distro. And something that used to really bothers me was the need to know that I have something installed on my machine with a hard dependence on other thing. So
Yeah.
how many times you faced issues with, oh, this Java version doesn't match with this other library, or this other tool needs a Java of, so I need to have like 3 Java installers on my machine so I can like control those things, and multiple problems like that. So why we can't think in our machine as we think on the language that we program? Like when we code Clojure, we think about all of those things, like the dependence of another
Yes.
namespace or the function, and why we don't think on how my machine is built, like what are the building blocks of my machine, like this program depends on this program that builds this whole interface and things like that. So Nix is actually a programming language. It's a functional programming language, and it's a package manager as well. So you could use Nix and as a package manager on multiple distros nowadays, Mac itself, for example. And NixOS is like the whole operational system using this language and those principles. So when I joined Nubank, I met um, a coworker that was starting to use Nix as well, and then I realized how powerful that was, and then I started to making the switch. So I'm now a Nix user for I don't think I think 5 years or so, and I use everywhere, like on my personal computer, on my company computer, and there are even Nix ops, which are Nix for cloud applications. For example, you can use Nix on like a Terraform thing or something to like versionate your
Yeah.
programs and things like that. And the magic of this is, for example, my company laptop just broke some years ago, and I need to replace with new one. And I most of the people that replace Macs and other Linux, they just think, oh my God, I need to install everything together. I need to like set up these and those other applications. And I don't remember how I did that. I do have like scripts, bash scripts version somewhere where I can just run, while I just grab the new notebook, the new laptop, and just run a single command, and everything was exactly how I had it before. Because the good thing about Nix is it's completely versioned as files. So it's you can like I have on my dot files on my GitHub my whole operation system. So if I just switch to another laptop, and this will be completely reproducible, so I can just run a command and it will take it's time to install those things and leave as I had. So I don't know any other distro that makes something like that. So it's really easy to tell other Nix users, how did you do that? Oh, it's there. You just check a page with Nix script that is doing something, and that will work for them as well.
Yeah.
So I think this is the advantage of Nix.
Yes. Yes. Like on Mac, I use Time Machine. It makes a backup every hour. Um, and basically, I can revert my machine to the state. Let's say it goes hours. Then when the space runs out, it reduces to days and weeks and months. But actually, yeah, I have like 2.5 terabyte drive connected to my computer, so I can go back for quite a while. And the latest update is 26 minutes ago. So if my computer will be destroyed in upcoming half an hour, I will come back to it. But yeah, but I think what it can't do that easily. Yeah, go ahead.
Yeah, like the backup is one thing, but I think having the code somewhere you can see and understand is really valuable.
Yes, yes, it's definitely valuable. I remember when people started. I liked it a lot. Ansible, server provisioning software.
Yeah,
Yes,
yeah. I
like
used
it
to
was
work.
basically declarative. It was declarative and not imperative. So you basically said that there are these applications with these configurations,
Yes,
and
it's the same idea. Like I think it's a really it's a little bit how can I say that? Like Nix is a pure language and immutable language. So one of the things that people face is that it everything that you install is goes to like slash nix slash store and a huge hash of things because
yeah,
this program should not depend on another program. You know, it must be pure and immutable, so you can easily reproduce that. It's like the functional language that we have. You know, so
yeah,
while I install knows that it needs to like, oh, I need to install this and that and just grab them together. No, Nix doesn't make like that. You know, Nix understand the versions and like the it should not couple one of the other and just link to them with a lot of multiple symbolic links to then make a program work, you know. So this makes a huge difference as well.
yes, yes. How does it work when you want to update something? Like, let's say, if you use GNOME or XFC, or like, how do you update it?
Yeah, that's a good question. I actually from all those years I changed a lot my NixOS. So I went to GNOME to BSPWM and then to Hyperland, Wayland. So I changed a lot of the things. And the funny thing and the cool thing is that I just change lines of code and just run a command to switch on my next boot or switch right now or like schedule to switch later. And if that doesn't work or doesn't feel right, I can just roll back to the previous version, you know. So NixOS has this like image that it takes from your system. So you can, for example, when booting, choose what version you want, you know, like from previous runs, or just update your code and generate a new one, you know. So this is really fast and really like it doesn't have the, oh my god, I deleted that folder and I don't have those files anymore, I should like start from
Yeah.
scratch. No, you don't face those problems.
Yes, yes. You don't face those problems. That's good. That's good. Uh, so, would you say that NixOS is suitable also for, let's say, more beginner Linux users?
Yeah, that I think this is the biggest issue with Nix because it's not easy. Like, it's way easier than when I started coding. Like,
Mhm.
uh, we didn't have like a lot of documentations we do have right now. But it's definitely something that is still not as easy to like just tell someone that started yesterday with Linux to use it, you know, because you need to understand some things like, oh, what is systemd, why I need this, what I should use as my um, desktop manager and things like that. So uh, there are a lot of low level things that you need to understand.
Yeah.
But I think the good news is you can start from, for example, just the package manager. You know, okay, I don't want to switch from everything right now. I can just have a separate package manager. Then I install Clojure, then I install my editor, and then this, then that, version those things, and you can just iterating over it. You know, that's how I did actually.
Yes, yes. When you install Nix, do you start like the installer lets you to pick what packages and window manager you want, and then it creates like the initial configuration? Or does it really start with like a command line, just kernel and maybe VI
Yeah,
or something like that?
I don't. Yeah, I don't think we are still at that point. Like the last time I installed, like we do have like images with GNOME that just work, and those things are actually easy and work really well. It does generate a really good starting point configuration for you, so you don't have to bother with that. I think it it starts to like being a pain in the ass when you need to like, oh, but I need this driver for my specific I don't know, laptop of this version, you know, like you need to understand a little bit the things. But yeah, I think it. overall, the trade-off is really worth, in my opinion. You know.
Is your Nix highly customized?
Yeah, a lot. Like I have my Dodge files on my GitHub page,
Uh-huh.
and it's a lot customized. Like I use Hyperland, which is a custom window manager with my NixOS and custom top bars and a lot of programs. So I think it's a little bit different from the user.
Yes, yes, yes. And speaking of customization, is your Emacs highly customized? Are you Emacs user? And
Yeah, yeah, a lot. Like, I started Emacs when I joined Nubank as well. So it was funny because when I joined Nubank, I just decided, okay, I need to learn a new language. I will switch my editor, my text editor, and I will switch my OS as well. So everything was, I
every,
changed it together. It was really difficult. I do not recommend doing the same thing, but in the end, it worked really well. Like I use mainly, I have my Emacs running under Doom Emacs. Like I tried different like flavors of Emacs, and I found that Doom Emacs is like the most modern one. It has a lot of good defaults, and it's easier to like disable modules, and you can just customize things as you want. So, and it's really easy to like explain to people how those models work. You know, actually at Nubank we do have like a one single command that installs Doom Emacs for people and just set up everything that you need to code, like Flutter and Clojure and things like that. So like that that is a fun fact actually, that the maintainer of Doom Emacs, that is Henrik, he is a NixOS user. So he understands a lot about
yeah,
those functional, and he was a lot inspired by those things. So you that's one of the advantages of doing Emacs, that is completely reproducible with files. So you can just have your files configured in one way, and you can just install it, and doing Emacs will behave the same. You know.
that's good. That's good. Speaking of new banks, so now you have team of hundreds of Clojure developers and thousand, a thousand something microservices, right? Um,
Yeah,
all of them in Clojure, most of them having their own database. Um, how does Clojure like scale? Um, is it do you have problems with latency between services, etc.?
yeah, that's a good question. Yeah, we have like thousands of services right now, and I think 2,000 developers working,
Okay,
not only Clojure, but uh, mostly Clojure. We do have like Python for some data specific things, uh, other languages for like low level things like Golang for infrastructure and things like that. But overall, it's Clojure. And since the beginning, there was this idea of make things scalable. So microservices was something that since the beginning was the point. So we don't have like huge old services. If it's a old service, it's an old microservice. So we do have like legacy and stuff, but not as much as the other companies I work at least. Um, and it's funny because when you say does Clojure scale on those things,
yeah,
uh, the we do face latency and lag issues, but it's funny because never it Clojure is the problem. Like
yeah,
it's mostly like how we coded our product or models, or for example the messaging. For example, we use a lot of Kafka here, and how we configure the producers and consumers, and um, I don't know, some issue with the connection with the database or something like that. So it's never Clojure the problem, you know, like when you have, we do have like a lot of problems, but we can't blame Clojure
yeah,
itself. You know, it's a language that scales really well, and those principles of simplicity and ease to use, is to build and compose with other libraries and functions and other microservices helps a lot, you know.
Yes, yes. You are also using data make, and if I understand correctly, you don't let multiple services to connect into one data make database. So basically, microservices own their own databases, right? How does it work? What do you do when microservices need to communicate and based on data, let's say, into different databases?
Yeah. Yes, we do have like the atomic for most services as well. And one of the rules we have is we don't access the same database. We don't have like shared database for different services. We just think, okay, we have this, I don't know, credit card model. So we have this credit card specific information, and this is the service specific for this credit card information. So any service that needs to reach this will know that this service needs this information, has this information, so it can request it. And basically, we have like two ways to approach this kind of problem you mentioned. That is the authority versus autonomy.
Hmm.
It's actually a pattern that is used across multiple languages as well, but we could choose like request the authority of the data, like the service that owns this data
Yeah.
and get this information, or we can have the autonomy to have this information on my database. So, for example, we do have like the uh, I don't know, a service that owns all the customers of Nubank. So we have like it has all the customers and only the customer information of the customer. Obviously. So, but all other services need to know about the customer as well. It doesn't scale doing multiple requests to this service all the time, you know. But for example, the service that does the transfer doesn't need like all the customer information, does just need like, for example, the ID of the customer, or I
Yeah.
don't know, the name or something like that. So we do have this autonomy approach, which is every time customer is created or changed, we produce to a message topic
Hmm.
with this service that is interested on this ID can consume and save the ID related to this transaction on their side. So when we do a transfer, we don't need to request the service because we do have the ID, you know. So this is the
Yes.
autonomy approach, is more event-driven approach, and I say it scales really well most of the time.
What's the decision making process when you have a new task, whether to extend existing microservices or when to start a new one?
Yeah, that's a good question. We don't have like a a canonical way to do that. I would say like there are hundreds of teams, so they have like different ways to handle those things. But most of the time, the team, if the team feels comfortable with a simple task, oh, okay, we need just to change this service and that makes sense. Um, we just go straight ahead. But if we need to elaborate or think a little bit more, we do have like whiteboard sessions to discuss how we should tackle this problem, and we have like ways to fix this. For example, we do have like decision matrix, so we discuss about the problem first. Uh, if it makes sense, how what is the problem that we are trying to solve? So this is the main uh, mindset we try to have, and we like elaborate all the possible solutions and the trade-offs between them before like, oh, let's just create a new service. We don't want to have like millions of microservices. If we are creating a microservice, we need to understand if it really makes sense to create this microservice. Obviously, we don't want to have multiple responsibilities in the same service,
Yeah,
but we don't want to create a microservice that, I don't know, just ask people what his name, you know. So,
sure.
uh, so this is the main approach we have, like discuss with the team, whiteboards and decision matrix, and collecting like feedback from people that are related to this approach, you know.
Yeah. Do you think the average size of microservice at Nubank is over time getting larger, or do you keep the same length, same size, let's say about 1,000 lines of code, and you are keeping this stable?
Um, I don't think so. I think Uh, it's probably increasing the code base of the services, but I already worked on multiple legacy services at Nubank. Like we had like a real a Microsoft that used to like have everything related to a feature, but this feature becomes so huge and famous across the country that uh, the Microsoft was handling with lots of things. So it was really a legacy and like becoming a monolith of this feature. So we decided to create different services to handle those features and doing migrations to these things. And like after 2 or 3 years, we deprecated this service and the service is not working anymore. So we do care about uh, how much how we are maintaining our services so we can scale and have faster iterations, A/B tests, and things like that. So, but overall, the code is increasing. But we always think about this. Like, is that a problem? We should are we having like maintenance issues with the service? Should we consider migrate those things? So this is something that worked really well, I think.
Yeah, at what levels or layers, if you will, you have tests. You like focus more on testing individual unit, like even one namespace or one microservice or a bunch of microservices at once.
Yeah, like Nubank is really focused on tests. So there are multiple kinds of tests. I think there are unit tests that are testing a specific function, usually a logic function or something that is pure. Then we have like the integration test. That is a test that tests the whole communication for a service. So for example, if the service has an endpoint to do, I don't know, do a transfer and save on its database, we do test this on the integration test. So we test that requesting this endpoint, it will produce a message and then save to the database. We do have like contract tests. So we have a really strong, powerful tool that we built in-house regarding testing if the A service is producing what B is expecting,
Yeah,
and vice versa for both HTTP or Kafka layers. Um, and we do have like multi-service tests that is the broader version of the integration test where you can have like uh, I don't know, I need to do uh, a credit card and I need to buy something with my credit card. I can have like, and these have, I don't know, 10 services involved, for example, for this specific feature. So you can have a test that tests that, okay, A should communicate with B, then C, then D, then E, and should expect this. So this is a multi-service test that we have.
there is. Yeah, I started prototyping the tool for testing exactly this actually, even in generative manner. But then life happened. But
Yeah,
yes, there are. It's super useful, especially yeah in longer running use cases, for example, and so on. And you need to test that it will ever finish and so on.
yeah.
Great. So the
I
next.
think it's really hard to maintain those things. Like we are facing a little bit of problems with because it's really a really complex environment, like having those all those kind of services there. But in the end, the trade-off is really worth it. Like it's the best way to test a whole feature.
Yes, yes. Now, speaking of people, so Nubank is hiring people very often who were working in other programming languages before, and they are able to onboard people and turn them into Clojure developers in a couple of months. So, what are the main programming languages people switch from?
Yeah, I think we can say that it's not easy to find Clojure developers around the world, but it's something that Nubank knows. It's something that it's hard to achieve. So we don't expect to hire anyone that knows Clojure, of course. But in the end, we discuss like things that are not coupled with language. So, for example, we do tests related to architecture of a service. So, how we solve this problem. So, like the logical thinking about this process. Um, and we know that if we hire this person, we'll need to teach Clojure for this person. So, we do have like a really complex onboarding of months that we have like courses and classes for those people, and a lot of material teaching how to learn Clojure. So we don't expect that you is hired and on the next week or two you already know Clojure. No, we know that there's a lot to understand, especially about Nubank and then Clojure and Datomic and how we use those both together, or the tooling that we have inside. So the onboard is really complex, but I would say that works really well because uh, it's really funny how people. It's always funny to see people knowing Clojure, especially senior developers, because they see things that other languages lack on,
Yeah.
and Clojure trying to fixing those things. So. But I think overall it works really well. Like the onboard is really complex,
What
and
are
the
your
person.
candidates? What are the languages they used the most in the past?
I think it's a mix of a lot of languages, but mostly Java, Python, Golang. I think that those are the
Is
most.
there if you have got a chance to speak with them, is there any difference in what they say about Clojure if they are, let's say, from dynamic language like Python, and if they are former Java developers?
Yeah, I think the most important thing that we see and is like the mutable, like how we think about mutability.
Yep.
Like uh, oh, you don't have like this variable value. You don't need to store those things. You need to think a little bit more functionally. Like how you can have a pipeline of things. You can have this data. You will pass to this function, and you have another data, and this then you can pass to another function, another data. So everything is data. The classical phrase. So this makes really easy to understand like the steps of the language. While people are working with complex mutability of having this variable with this value, but on this stage it's null, and then it changes the value after something happened. So it's hard to understand those things.
Yes, yes. Also, maybe in expectations of how expressive the language could be,
Yes,
because so in Clojure, expressivity, it depends on situation. You might have a situation where nothing compares to Lisp's, or let's say homo-iconic languages. Then might have pretty standard scenarios like load data from database, show them in form, validate and form and store it in database. And I would say this code will be as long in Python as in Clojure, because it's 10 lines of code more or less. You might make a function that like makes an abstraction for all this, but you can do it in Python. While I guess in Java, where especially enterprise Java, the culture is more like be more abstract, split problems to more classes. And also, it might take a while for people suddenly to get used to a model where you are really programming and not just like modeling the world in classes. And
exactly.
yeah, absolutely. Would you say that people who are attracted to Clojure are somewhat different developers from, let's say, people in other languages?
Uh, I would say yes. I think people that seek closure are usually more senior developers,
Mm.
people that already face different uh, kinds of flavors of language. And it's funny because when you have like a more junior developer, closure tends to scare those people, like, oh my god, what are those parentheses and things like that? How should I use that? And while for senior developers, they think how that how does that work? How does this scale? How can I have like a whole namespace with those things and people actually understand this? So it's funny to see how things compose easily. I think the
Yeah.
senior developer realized that soon, that it's easy to have specific responsibility functions. And what you mentioned about the same language, the same amount of code between Python and Clojure. It's funny because when you have like those functions defined, for example, at Nubank, with one line you can produce a whole thing to a Kafka topic using all the configurations we have with just one line of code, because it's just a function that calls another function and it's composing all those stuff. So I think that senior developers, I see a lot more senior developers approaching Clojure because they see those values, they understand those things.
Yes. Yes. It's interesting. Like Clojure is super powerful, and yet it makes it harder for you to make bugs. So you end so I completely like. I often say that some decisions in Clojure design are there, and to understand them, you must have been through enough pain in other programming languages to understand them. And
Yeah.
yeah, which like includes software transactional memory, immutability, topics around this. Even like using quite basic data structures instead of like encapsulating and building hundreds of different types for the same things, just named differently. Um, which like if any Java developer is now listening to me, it's exactly the opposite of what those people are being told for decades. Um, but it works absolutely great for a closure.
Yes.
Uh, so I guess you can't imagine using any other language, right?
Yeah, I think I'm pretty close to the community, as I was never close to any other language. And I think this is another thing that Clojure brings me a lot of joy. It's like the community. Like, it's incredible how we are smaller than other language, but at the same time, it's so many people helping each other. So we know a lot of developers from a lot of toolings. So, and when we face some issues, we can just ask for help on a channel, on Clojure and Slack and something like that. So
Yes.
it really works. And I think I'm pretty close to the community. So, and all those things we discussed, and like the libraries I maintain myself, so everything is really connected. So that's one of the reasons I don't see myself working with other languages, because I love all those stuff.
Yes. Yes. Absolutely. Yeah. The Clojure like is fantastic. It's great community, and you're absolutely right. I think one of the reasons might be that Clojure is very high level, but it's also practical language, so it attracts people who really use it.
Yeah.
When I was researching was the situation with, let's say, Haskell, it's significantly more academic. And then when you look at, let's say, common list communities, it's much smaller because they don't have that JVM ecosystem that's feeding them with fresh libraries and ability to connect to any database, any service, parse any file, and etc. What we have here in Clojure.
Yeah, and it's funny because I knew people here in Nubank that went from those languages to Clojure. It's funny because they realize all those things and they understand the value of the GVM when they have all the things that they had on Common Lisp and Haskell and things like that, but with the JVM. And this is really funny to see how people realize how those things work really good together.
Yes, yes. I was implementing one library from Python to Clojure, which is parsing or reading and working with Git repositories. And Python has a library for Git repositories, and Clojure has like there is JGit from Java, so I can use it. So I was able to import it and start working with that. If I used a language where basically you don't have such a runtime and such libraries,
Yeah.
it might be an issue because you might need to implement some Git internals or like run command line and control Git from the command line, which might be clunky, slow. Um, it might be prone to break in a new Git versions and so on. So like these situations are where I am really grateful
Yeah, the
for the
interoperability with Java really helps a lot. Like most
yes,
of the toolings are made using those things because we do have like the Javas, that
yeah,
are back, you know. Yeah.
yeah. Also, it's fast. When you look at Peter Stromberg, he is doing a lot of those like on LinkedIn. He's posting on LinkedIn those like the algorithm in the various languages that like pinging ball, and the faster it goes, it means the faster is the language, and Clojure is almost always like one of the fastest languages out
Oh,
there.
cool.
Which um, which is great. Like Java is hyper optimized
Yeah,
language, and there is not a lot of penalty in using of Clojure. Like if you don't use lazy sequences, it's really high performance language, and at the same time, it's high level language with lots of ecosystems. So yeah, it has a lot of advantages.
I think this is a really good advantage because the Clojure code base is really small
Yeah.
compared with Java code base. Like we do have Clojure working and years of Java development improving the JVM itself. So we do earn all of that for free, you know.
Yes.
So that's really cool.
Yes. Yes. That's absolutely truth. Now I have last question, and it's how can people support you?
Oh, cool. So I'm currently working on mostly tooling related to Clojure, and those are all open source projects, and I keep them on my GitHub, and I have my GitHub sponsor page. So if you want to, uh, you can contribute with not only supporting me on my GitHub as a GitHub sponsor, but also contributing using those toolings or testing, opening issues, and you can call me on Clojure in Slack. I'm always available there. So, yeah, I think that's it.
Perfect. Perfect. Thank you very much,
Thank,
and I hope we will have a chance to do a follow up in the future.
yeah, me too. Hope. Thank you very much for this interview. I really enjoyed.
Thank you too.